This lecture will be learning about decision trees. Decision trees are used for classification. And what is classification? Classification is a form of data analysis that extracts models describing important data classes. That means we can identify this particular record belongs to which class. So the classes are definitely categorical. They could be discrete or they could be unordered. So essentially they cannot be numeric. They should be discrete or unordered. Our class label should be of these two forms. Like if you want to identify whether a particular record, depending upon the values, the particular bank can give a loan application to no, or the loan application can be either safe or risky. So the safe or risky, these are categorical labels. So classification can be used in numerous applications, like if we want to detect fraud, then we want to target marketing, we want to find out the performance of the prediction, manufacturing and medical diagnosis. So there are innumerable applications of classification. So for the purpose of classification, what for this is an example, like a medical researcher, he wants to analyze breast cancer and want to define whether the treatment A will work on this particular condition or treatment B or treatment C. Or if there is a bank who is giving the loan, then whether the loan can be given to particular customer or it could be safe or risky for the loan application data. So like in similarly in a marketing application, whether the output can be yes or no. So depending upon the categories which are defined for the class label, we classify the tuples or the records. So data classification, in order to perform that, we perform this classification with the help of two-step process. And in the first step, this is called a learning step, where we construct a model with the help of the training data. And then once the model is constructed with the help of the training data, we have another step, and that is called a classification step. In the classification step, whatever test data we have, then the label or the class label of that test data is predicted with the help of the model we have constructed in the learning step. So this step is called as a classification step, where we are predicting the classification of the label. So as I have told you, in the learning step, the model learns with the help of the training data. So we provide training data to the data set, and once that learning step is over, the model is built, and this model, once built, can be used to classify the unknown tuples. So for example, here you can see this is the training data. This training data has been given to the classification algorithm. This algorithm makes some rules. Depending upon the output of these class labels, some rules are formed, and these rules are definitely in the form of if-then rules. And once those rules are formed, then the test data is supplied to the model, which consists of classification rules. And once the test data is given to it, then the decision of the test data is checked to find the accuracy of the test data. And once the model performs well on the test data, then it can also work for the new data. So this new data consists of all the attributes, but it does not contain the output label. So this output label is predicted by the model. Now, what is the difference between the test data and new data and this training data? See, training data is the data which is given to the model for training. So here we are providing the loan output class label along with the name, age, income. So with the help of these three attributes and the output of the loan decision, it builds the data. Now when we give the test data to it, so this test data is the data which was not given to the model for training. So when we give the test data, and this test data uses the classification rules which were earlier formed. Now we check whether the output given by the model is same by the to the output that was given in the test data. So here also we have the output label, but this data was not used for training the model. This data is only used for testing the table, testing the model. But the difference is that this was not given. So here we can test the accuracy of our model on test data. So if the model performs well on test data, then it can be used for new data where the loan decision or the output label is not given and the model can predict it accurately. So accuracy of the test data, if it is good, then the model can be used for the classification of the new data. So because here, while as we have seen, we are providing the output label here for the training data. And once the output label is given, so this kind of learning where we are providing the output label of the class, then this kind of learning is called as supervised learning. So because the class label of each training tuple is provided, we call this as supervised learning. And in unsupervised learning, which is clustering is an example of unsupervised learning. And the difference between the supervised and unsupervised learning is that in the unsupervised learning, the class level of the tuple is not known, and how many classes will be there for the output label. So that is also not known in a unsupervised learning algorithm. Now, how do we measure the classification accuracy? In order to measure the classification accuracy, there are certain metrics which are used, but the predictive accuracy of the classifier should be, because if we give the training data to the model, then the model may learn the training data, and then it, whenever a new data is given, it may not perform well. So if the training, if the accuracy of the training set is very good, it is good because the model has learned the training data, so it tends to overfit the data, and this has bad, this may give the, not inaccurate results for the test data. So every time we do not check the accuracy of the model with the test data, we every time check the accuracy whether that particular model can be used for the new data. So we test the accuracy of the model with the test set, which it is a set in which we have the output label, as I told you earlier, but this test set was not given to the model while training the model. So if the model performs well with the test set, then only it can be used further. So in order to find the accuracy of the classifier, this test set is used. Because why this test set is used? Because the model can overfit the training data, it learns the training data, and it may not perform well on the new data. So we use test set. So the accuracy of a classifier for a given test set is the percentage of test set tuples that are correctly classified. So in order to measure the accuracy, how much tuples or how much records were correctly classified by the classifier, the percentage of that is called as the accuracy of the classifier. Now, in order to classify, here we will be learning about decision trees. So decision trees are used for classification purpose. And in the decision tree, what we do is we create a flow like tree-like structure where each internal node denotes a test on an attribute. So if our tuple contains certain attributes, then if for at every node we test some attribute, which attribute that will be, we'll be learning further, but definitely at each node there will be an attribute, and depending upon the number of values in each attribute, there will be any number of branches. So if an attribute contains three different values, like age, it can be youth, middle aged, and senior. In that case, the tree can have three different branches. And now each branch represents an outcome of the test. So whenever a node is there, definitely some outcome will be there, and that outcome is represented by the node. And then finally the tree is grown, and ultimately we reach at the leaf node, and that leaf node contains the output class label. So at the leaf node we have the class label, but in between we have the nodes and the branches. So nodes represent the attributes and branches represent the values of those attributes. So here you can see that here is a tree, this age, student, and credit rating. These are the different attributes in our data set. And there are three branches earlier. So this youth, middle aged, and senior. So these are the three different values of attribute age. Student, no, and yes. There are two different values of student. It may be a student, whether a person may be a student or person may not be a student. So these are two different values, no and yes. Similarly, credit rating has two different values, fair and excellent. So these are, and yes, no, yes, yes, no, yes. This is the output label. Now, when a person is middle-aged, loan application can be granted. So in that case, we do not require to find out whether he is a student or credit rating. So that means if all the tuples are correctly classified, then no further test is required. So when a leaf is reached, we stop the tree at that particular point. So when the attribute is middle-aged, all the persons were given loan. So here the output is yes. So no further tree is drawn. But here, if the person was youth, we again had to ask whether the person is a student or no. Depending on the output, the class labels were given. So what I want to say is that once the output class is reached, then we stop building the tree. Now, decision tree classifiers are very popular because it is very easy to learn, and interpretation of the tree can be done very easily, and moreover this model does not require any domain knowledge or parameter setting. So a tree will be built because what methods we are using to build the tree, that method we'll be discussing shortly. But definitely, if a person does not have any knowledge of the problem domain, even then decision tree classifiers perform very well. So these trees are very popular. And secondly, the interpretation of how the output has come, that is also easy, and it can handle any number of attributes. If your data set has contained multiple attributes, even then decision trees can handle those attributes. And decision tree classifiers have a very good accuracy also, and they are very simple, they are very fast. So due to these properties, the decision tree classifiers are very popular. Now, as you had seen here, when we are building the tree, this age attribute has come up, and why not student as a root node, or why not credit rating as the root node? So in order to build a tree, we perform certain tests to find out at which attribute will be used at what point of time and how. So that tests are known as attribute selection measures. So whenever we construct tree, attribute selection measures are used to select the attribute that best partitions a tuple into distinct classes. So several attribute selection measures are there. We use those attribute selection measures to create the tree. If I say creating the tree or building the tree, that means which attribute will be testing at a particular point of time. So when decision trees are built, many of the branches may reflect noise or outliers. It may happen with because whenever you are training data, that training data may contain some noise or some outliers. So that will also be mapped. So whenever our tree depth is very high, then that noise or outliers are also mapped. So in order to remove those noise and outliers, what we do is we perform tree pruning. So what tree pruning means is that we remove the, we are not creating the tree until and unless each of the partition is consisting of a single instance. We prune the tree in a way that every partition may have 4 or 5 instances, so that even if every partition which is made by the tree may not be a pure partition, that means when I say pure partition, that means every partition consists of all the tuples belonging to the same class. So we do not build a tree up till a single node at each leaf, single tuple at each leaf, but we cut the tree. This is done in order to remove the noise or outlier, or this is done to lessen the overfitting of the data, because if noise and outliers are also there, our tree is going to learn that also, and then it will overfit. So that tree will work good on the test training data, but it will not work good on the test data. So we prune the tree to identify any noise, and this may help in improving the classification accuracy on the test data. Although classification accuracy on the training data will be reduced, but this kind of tree pruning will help in increasing the accuracy of the unseen data. Now there are, as I have told you, there are certain attribute selection measures, and ID3, C 4.5 and CART. These are 3 different attribute selection measures which are used for decision tree constructions. So this ID3, whichever algorithm we use, so these algorithms will definitely require some amount of parameters. So the parameters which I used to build the tree are three parameters. One is the D. D represents the data set. Attribute list is the attributes in our data set, like age, then student, then credit rating. So these are the different attributes, and the attribute selection method. Now, as we have discussed, there are three different attribute selection measures. So which attribute selection measures we are using? So depending upon that, we perform the classification using decision tree. Now here we are discussing only one method of decision tree induction, and that method is used in ID3. So let us discuss that. So attribute selection measure is a heuristic for selecting the splitting criteria. Which attribute will be chosen as a splitting criteria to, first of all, it will be becoming the root node, then thereafter at other branches which splitting criteria will be using. So attribute selection measures are also called as splitting rules, and splitting rules will be using, or what are the different attribute selections. As we have learned, there are three different algorithms: ID3, C4.5 and CART. So in ID3 we use information gain, in C4.5 we use gain ratio, and in CART algorithm we use Gini index. So these three are the three different attribute selection measures which I use in three different decision tree drawing algorithms. So we'll first of all we'll be learning about information gain. So information gain, it is an attribute selection which is used in ID3. Now, whenever we use this method, we start with the first node, and that node n represents or holds the tuples of partition D. So whenever we are at every point of time, we are creating partitions, and every node create all the tuples belonging to that partition. So the attribute with the highest information gain is chosen as the splitting attribute. So we'll find out the information gain for each attribute, and out of those attributes, whichever attribute results in the highest information gain, they will split the data set based on that attribute at any node n. This attribute, why this attribute is chosen? Because this attribute minimizes the information needed to classify the tuples in the resulting partitions and reflects the least randomness or impurity. When I say least randomness or impurity, that means my partitions are most pure partition. When I say pure partition, that means every partition consists of tuples belonging to one class, not two different classes. So this method helps us in reducing the number of steps and tries to find out partitions that are pure partitions. Now, in order to use this information gain method for decision tree classification, we first of all find out the info D. So D here represents the data set. Now I is equal to 1 to m. M means the number of classes. If I say there are two different output class labels, yes and no, that means the value of m is 2. So for that, if I want to find out information, the formula is sigma I is equal to 1 to n pi log to pi. So pi is the probability of the tuple belonging to class I. So if I is equal to 1, that means yes class, then the probability of the tuples belonging to yes class. Log 2, then again the probability. Now once again, because it is sigma, this time next time the value will be 2. So the probability of the tuples belonging to class no, and log 2 probability of the tuples belonging to class no. In this way we find out the information of the entire data set. This information is also called as entropy of the data set. Now, once this information of the data set has been found, we now find the information of the various attributes. So, if the attribute, suppose age is one of the attributes, then at the next step, I'll be finding the information of the age attribute. If the credit rating is one of the attribute, I'll be finding the information of the credit attribute. If the information of if student is one of the attribute, then I'll be finding information student. Now what this formula says is j is equal to 1 to nu. So this nu represents the number of values that an attribute has. For example, if it is age, then youth, middle-aged and senior. So the value of nu is 3. If it is student, yes or no, then the value of nu is 2. If it is credit rating and yes or no, then the value of mu is 2. So for every value of a particular attribute, this dj represents how many tuples have that particular value of, like, if it is age, how many students, how many age, how many records are there with the age is equal to youth. Then the total number of tuples, then the information of the this particular partition, and this particular partition information is once again received with this particular formula, which is used for information D. Now this time we'll be using that particular partition in which the age is youth, or age is middle aged, or youth is age is senior. So this info dj is the information of that particular partition. So for every partition, like age is equal to youth, age is equal to middle aged, age is equal to senior, for every attribute value we'll be considering and then summing them all up to find out the information of one attribute. Now this information has to be find out for all other attributes. So when we find out all the information of all the attributes, then we can find out which attribute is important. So after finding the information of the data set, after finding the information of each of the attribute, we calculate the value of gain. So here we can see this is our data set which contains 14 tuples. So first of all, we have to find out the information of the data set. In the data set, we can find out that there are total 14 tuples, and out of those 14 tuples, 9 tuples belong to class yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 tuples belong to class yes and 5 tuples belong to class no. So information of a data set is probability of tuples belonging to class yes, and sigma probability of tuples belonging to class no, and the formula was pi log to pi, sigma minus pi log to pi. So this is for yes class and this is value is for no class. So total information of the data set is 0.940. Now this is the information of the data set. Now we need to compute the information of every attribute. So suppose I take the case of age attribute. This age has 3 different values: youth, middle aged, and senior. So I will find out how many tuples belong to youth, how many tuples belong to middle aged, and how many tuples belong to senior. So here I can see 5 by 14. That means there are 5 tuples that have age is equal to youth, 4 tuples that have age is equal to middle aged, and 5 tuples that have age is equal to senior. Now out of those 5 tuples, how many of those tuples whose age is youth, how many are yes and how many are no? Because this part in the bracket, it is for the information of that partition. And whenever, and here as we have seen, we have calculated the information, and whenever we calculate the information of the partition, that means how many belong to yes class and how many belong to no class. So this 5 by 14 is the number of tuples that belong to youth. This out of these 5, 2 belong to yes class and 3 belong to no class. Let us check this. So here youth is 1, 2, 3, 4, and 5. So 5 tuples are there. Now how many are no? Youth, no, no, and no. So 3 tuples in youth belong to no class, and this is yes and this is yes. 2 tuples belong to yes class. So here as you can see, 2 belong to yes class and 3 belong to no class, and this 5 is the number of tuples belonging to youth. So this is the for the age is equal to youth. Now age is equal to middle aged. So there are 4 tuples out of 14 whose age has age is equal to middle aged. Now all the here we don't find the second number. That means all the tuples that have age is equal to middle aged, they belong to yes class, because here we don't find the second figure, and we had also seen that in the decision tree diagram also, that if age is middle aged, all the tuples belong to yes class. So in our data set also we can see that all the tuples of whose age is middle aged, they belong to yes class. So here middle aged yes, middle aged yes, output middle aged yes, and middle aged yes. That is why, and this middle aged yes. That is why here we don't have the second figure of the no class. So all the 4 tuples have age is equal to middle aged, and they all belong to yes class. Now similarly, the third figure is for the age is equal to senior. So total there are 5 tuples. In those 5 tuples, 3 tuples belong to yes class and 2 tuples belong to yes class. So when we sum them up, it comes to 0.694 bits. So this was information age, and earlier we had calculated information of the data set. So I subtract these two things and I can come up with gain age. Now this is gain age is only for one attribute. In the similar fashion, we can compute the gain of other attributes and then find out which gain has the highest information gain. So gain income is 0.029, gain student is 0.151, and gain credit rating is 0.048. So we see that gain age is maximum. So because age has the highest information gain, it is selected as the splitting attribute. And that is why when we saw the tree, it was age at the first and then further we had built the tree. Now once we have partitioned the tree with the age, now further, because this partition is pure, we will not be further partitioning this, but here this is student and this partition may consist of both the classes. So here once again we will be further partitioning our data set, and here also we will be further partitioning our data set, and for middle aged the partition will stop. Here you can see, so this partition consists of no and yes class. So this is not a pure partition. This also consists of yes and no class. This is not a pure partition, but this partition consists of all the yes class. So we will stop here for this middle aged, but here once again we will draw a tree and find out whether we will choose income, student, or credit rating now. After this, which attribute will be chosen? In the tree shown earlier, we had seen that there was student. But in fact, in reality, we will once again find out the same procedure like we had conducted for age. This time it will be age attribute will not be considered any further, but this time for the left portion of the tree, we will find out the information using income, student, and credit rating, and whatever attribute gives us the maximum information gain, that will be used in splitting criteria. If student attribute has a maximum information gain out of these three attributes, then this will be chosen as a splitting attribute further. Then once again, in that splitting attribute, if after choosing student as a splitting attribute, if all our partitions are pure, then we will not further classify, we will not further draw the tree, otherwise we will further draw the tree. But here as you can see, student no, 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 and every the class level is also no. So I think this student criteria attribute used for partitioning, that will be the best. So it will give us pure partition, and this left side tree will be stopped here. Similarly, for the right side tree, we will once again consider these three attributes, and whichever attribute gives us the best splitting. When I say best splitting, that means pure partition, then this will stop. And as you can see, fair, 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 and all the tuples belong to yes class. So this will give us maximum information gain. So for the right portion of the tree, we will consider credit rating as the splitting criteria, and this will give us the partitions which will be pure. Because now all our partitions are pure, we will stop the tree at this particular point.